Okay, example 17.2 on 447 if you want to take a look. And we're looking at newts. Creature like this, you may or may not have seen them. But we want to be able to know how fast their skin regenerates when it's been cut. And when I started reading the procedure of this study, I felt a little grossed out. It feels really cruel to the newts, but basically they anesthetize them, so give them some painkiller, make a razor like slit in their skin, and then see how quickly it heals. And we're given 18 data points measured in micrometers per hour, how quickly the skin is healing. What we want to do though is we only have data from 18 different newts, and we want to make an estimate for this particular breed of newt, what is the average skin healing rate. And to do that, we're going to use a confidence interval. Confidence interval allows us to make an estimate roughly where the population mean is. So population would be all newts of this breed, not just the 18 in our sample. So the formula here should look familiar from the previous chapter. We basically have the sample mean is our best guess, 25.67 micrometers per hour, plus or minus, and instead of a z-star, we have a t-star, critical t-value. We'll take a look at just a second, and then a sample standard deviation that's given to us, 8.324. Because we don't have the population standard deviation, which is normal, you very rarely have that, we're using the standard deviation from our sample of 18 newts. So the hardest thing I think here is this t-star. First of all, we need to know what kind of confidence, and I think the question tells us it's 95% confidence interval. The second thing we need to know is degrees of freedom. And so degrees of freedom, when we're just dealing with a single sample like this, is n minus 1. It's one less than the sample size. Our sample size is 18, so our degrees of freedom is 17. So 95% confidence, 17 degrees of freedom. Let's look that up. Okay, and if we go to table C, you can see the different confidence levels here. We want the 95% confidence column, and over here we have degrees of freedom. Note that it's not the sample size, it is the degrees of freedom. So we go with 17 was our degrees of freedom. Come over here to the 95% column and you see 2.110. So that's where we get our 2.110. Putting it all together, subbing in these numbers, we get this equation here. We're taking 4.14 away from this sample mean and also adding it onto the sample mean. Do try to keep them in order so that your first number is lower than your second number. 21.53 to 29.81 micrometers per hour. What does that actually mean? It means that we're 95% confident that the average healing for all newts, not just our 18, we already know our sample is 25.67, but we want to know the mean for all newts. So that mean for all newts of this species, somewhere between these two boundary points, somewhere between 21.53 and 29.81 micrometers per hour.